Let's start our SQL instruction from create and drop. So as we discussed previously, in the data lifecycle, the first step, of course, is always to create a data set. SQL does this create by using the create statement. First of all, there is this create database statement. Normally, a relational database management system will create a default database for you when it was first generated. However, based on security concerns and performance issue or other concerns, your information technology guys, the team, and those database administrators will usually create different database for a different team. Usually it's for security concerns. Some people should only see a part of the data, right? And this step usually is only executed by database administrators. We as a data scientists are not involved in this. So this is something that you should know about, but I don't expect you to run into this statement in your day-to-day work. A more likely usage of create statement is creating a table. We already said each table represents a relation and each row represents a tuple. And each column in the table represents an attribute. So defining the table is basically describing the columns of the table, the attribute, what's their name, their data type, and the order they show up. And then followed by populating the table, which is inserting rows into the table, is taken care of by the insert statement that we are going to cover in later courses, in later sessions. So in the create table statement, we directly map a relation to a table. For example, we have a relation instructor here. This instructor has two attributes. One is the instructor name, which also is a primary key, and another attribute is instructor affiliation. These two, right now I'm not showing that, but let's assume that each have a data type. Instructor name can be characters up to 100 characters. And the affiliation can be another text field, string field, that can be up to 10 characters. And that's the create statement, create table statement that will corresponding to the creation of this relation or mapping this relation into a physical database table. It will be a create table instructor followed by two column definitions. The first is instructor name with a character up to 100 characters, with a text up to 100 characters, and the primary key definition, primary key keyword, which instructs, which tells that this field, this attribute is the primary key of the table. Then followed by another column definition of instructor affiliation, a text up to 10 characters separated by a comma. So in a create table statement, in a more general sense, the statement will start with the keyword create table and followed by a table name. The name must be defined. Usually it's the relation name. You will also followed by the parenthesis. Inside the parenthesis is the table content. The table content consists of column definitions and table properties. They're all defined inside the parenthesis. The name of the table and the columns has certain rules, and these are the general rules. Not all database have the same rule, but basically these are the conventions that I suggest you to follow. First of all, it shouldn't go beyond 30 characters or 31 or 32 around that. anything more than that, your computer may be able to accept it, but your table user will have trouble in reading. It will start with a letter or an underscore, then followed by a letter, a number, or multiple letters, numbers, and the underscore, or the combination of those. There should be no space, no special characters. If you want to include space or special character, or if you want to start the table, the name with something other than the letter or underscore, like a number, for example, 2022 sales, then you can put a double quote around the table name or a column name. In this case, it will become case sensitive. Remember, table and the column names are not case sensitive unless you put quote around it. Some valid name, student ID, teacher name underscore, or without the underscore, or with numbers, or with a multiple underscore and with underscore in front. Some invalid code name, like student ID, here we have a space in between student and ID. This is invalid. We have a $ here, or with the name starts with a number, or sometimes it's too long. In fact, in the latest PostgreSQL, this column name is not too long anymore. But in most relational database, this name will still be too long. If you want to make these a valid name, you need to add double quotes to make them valid. Okay, so now that we know the name, how the name can be defined, let's take a look back. We will have a create table keyword followed by the table name. The name has to be a valid name or with a double quote. And usually we will use a relation name. And that's why I said a little bit of the convention can help, because you will have multiple relations in your data set. If you think about the way you design your data set, you want to make sure your relation names are precise and meaningful. You want to have a relation name that can reflect what the this relation really is about. You can add like a $, you can add space, but a name too long usually will not be accurately describe what the relation is about, right? Usually this is the case. The longer your name is, the worse the less precise your relation is. This may be counterintuitive, but in my opinion, a long name usually means you do not really know what you are doing, right? But if you really know what this relation is about, you will be able to come up with a name that is less than 32 characters. 32 characters is a large number of characters. Then once you define a table name, you will use the attribute names as column names. Each attribute is one column, and then you will add data type to each column. Then you will add comma to the end of all definitions except for the last one. Or on another way of expressing that is use comma to separate column definitions. There's also table content that will be followed by following column definitions. In defining a table, you will define the column first, then you will provide table properties. There are multiple ways of multiple styles, multiple types of table property. One of them is primary key. You can define primary key either as a column constraint or a table property. Either way, if it's a table property, a column property, you will add a primary key after the column data type as a part of column definition. But if you want to define primary key as a table property, then you will have a separate column, separated row of code after all the column definitions has been defined, right? So after both column definitions are defined, you will add a primary key, which is a table property separated by a comma inside the parenthesis. Remember, all the column definition and the table property must be inside the parenthesis following the table name. This is how you make sure the database understands that everything inside this parenthesis belongs to that table. And column definition usually starts in its simplest form is a column name followed by data type. Again, this column name should be precise, and it shouldn't be like something so long that you cannot even type it in one paper, right? An accurate name usually should not be going beyond any like 32 characters. Then column name followed by data type and the sum table column constraints. And these constraints can really depends on how you will define your relation. If it's a primary key, then you can add a primary key constraint. Or in this case, you can say that's an attribute property. Then it can be some other column definitions, like it's a unique, right? This will be defined in create statement. Or you can also append it after you create a table. You can create a table first without the column definition, then append constraints, which we will talk about in future sessions. Some example of column constraints. For example, if let's say instructor is social security number, that has to be unique, right? So in this case, we can add the keyword unique after the data type, character 9, and make this unique column. Once it's defined as unique, anytime you want to populate the table, you have to ensure the data is properly defined. If you have already get an instructor record, which has a social security number of 1, 2, 3, 4, 5, 6, 7, 8, 9, then you will not be able to insert any new tuples with the social security number, with the same social security number, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what the unique constraint does. And put the constraint on the column that each value inside has to be unique. Each tuple must have a unique value in this attribute. And the default value is another constraint you will run into. For example, if most of the course has a credit hour of 3, I can define this as default 3. So when I create insert statement, I don't need to explicitly specify that this credit hour is 3. I'll just leave it. I will just not mentioning that. Then database will know that I should put a default value 3 inside here. And there are much more that you can think of. But we're not going to go through these details here. But anytime you see a column name followed by a data type, followed by something else, you will know that's a column constraint. And exactly what this constraint does, you need to consult the database manual, because there are many different constraints serving different purpose, and different database may have different definitions of this constraint. So it makes sense. Once you see those, you understand those are column constraints. You understand. You should go to database manual to check what it is about. So let's come back to primary key a little bit, because this is something that is quite unique in the sense that it can serve both as a column constraint and a table constraint. However, there is a catch that the primary key column constraint, the primary key definition can serve as a column constraint only when the primary key is a single column key. So if it's a primary key, if it only has one column, like here in the instructor table, only name column is the primary key. Then you can put the primary key keyword after the name column, the instructor name column definition, the table, the column name and data type, as a part of the column definition, before the comma, that's when you can define primary key as a column constraint. If the primary key is a compound primary key, if it contains multiple columns, let's say in this version of instructor table, the primary key consists of 2 columns, both the instructor name column and the affiliation column. As I intentionally remove the instructor, change the instructor affiliation to affiliation, just to make you aware that this is a different definition. So in this version of instructor, the primary key consists of 2 columns, instructor name and the affiliation. Then you cannot put primary key after either column or both column. You have to use a table constraint. Put a primary key with a keyword with a parenthesis and put both columns name inside here. That will end up as a primary key, parenthesis, instructor name, affiliation, closing a parenthesis. That's how you can define a primary key as a table constraint. Now, this is the only way to define primary key when you have a compound primary key. And I do see the most popular mistake, the most common mistake students make is when they run into a compound primary key, they will put the primary key keyword after each column in the primary key, which is wrong. So it will be like instructor name, char 100 primary key, followed by affiliation, char 10 primary key. This is wrong. You have to define a compound primary key as a table constraint. It will be like primary key, parenthesis, instructor name, and affiliation. Another thing to note is if you only have a single column primary key, you can also define this as a table constraint. In this case, it will be the same as this table definition, just that you only have 1 column inside the parenthesis. Let's say if the instructor name is the only primary key, only column in the primary key, then you can just remove this affiliation. It will be create table instructor name, affiliation, primary key, parenthesis, instructor name, followed by the closing parenthesis. So you can define primary key as a table constraint, even if the primary key is single column. Now, after you create a table and after you do all the manipulation, reading and updating, you can drop it. The statement used to drop table is drop table, table name. It will drop table at a time. Remember, you cannot drop multiple tables with this drop table statement. You cannot say drop table, table 1, comma, table 2, comma, table 3. You only drop 1 table at a time. And of course, we also have this drop database statement. But seriously speaking, drop database is a very serious operation. And usually it's reserved for DBA. And usually this involves a lot of backup. When DBA drop the database, inevitably they will take a backup just in case someone later realizes that there are some information in the database. So these operations are not performed by data scientists. They are performed by the IT team. So in your regular job, you shouldn't encounter this. You shouldn't be using this statement at all. But this is just a FYI that there is this SQL statement.